time we're going to look at speed calculations again, but we're going to focus on a broken journey. This is a journey that stops and starts, and even though you already have the speeds, they're average speeds and you can't average averages. We're going to go through our standard problem solving technique. Especially as the problems are getting more complicated, it's important you follow the steps, that you underline key points, make a list of the variables, write down the formula from your data sheet, substitute values, remember units, and is it a scalar or a vector quantity. Let's look at our first example. Lauren walks to her friend Clorinda's house at a speed of 5 meters per second and takes 2 minutes to get there. She stops and have a chat, and then they go to Mount Lawley. They walk to Mount Lawley at a speed of 2 meters per second and take 67 minutes to get there. Calculate Lauren's average speed. Now, Lauren's average speed cannot be the average between 2 and 5. So the average between 2 and 5 is 3.5 meters per second. It can't be that. And the reason why is she only spent 2 minutes travelling at 5 meters per second, but she spent 67 minutes travelling at 2 meters per second. So these have to be tackled as a broken journey. And I think it's always easiest here to divide your page up into sections. So we're going to have journey 1 and journey 2. Here we're going to do our final calculation. So in journey 1, she had a speed of 5 meters per second and a time of 2 minutes, which is equal to 2 times 60, which is 120 seconds. We need to find the actual distance travelled in this time frame. So we go speed is equal to distance on time. The speed was 5. The distance we don't know. The time was 120. And this comes out to be distance is equal to 5 times 120, which is 600 meters. So now we have the time frame that she travelled this speed at and the distance that she actually travelled. Let's look at journey 2. In journey 2, she travelled with a speed of 2 meters per second, a time of 67 minutes, which becomes 67 times 60, which is 4,020 seconds. Now, once again, we're going to find the distance. So speed is equal to distance on time. The speed was 2. The distance we don't know. The time was 4,020 seconds. So the distance is equal to 2 times 4,020, which comes out to 8,040 meters. So now we have the distance travelled in both journeys. So we can now find the total distance, which is equal to 600 add 8,040. And this comes out to 8,640 meters. We also can work out the total time, which is 120 and 4,020, and this comes out to 4,140 seconds. So now we can find our final speed, or our average speed of this journey in total, which is equal to distance on time. So this is 8,640 divided by 4,140, and this comes out to be 2.09 meters per second, which is pretty logical because she spent 67 minutes travelling at 2 meters per second, so it shouldn't be, whereas she only spent 2 minutes travelling at 5 meters per second, so she should have a value closer to the 2. Let's try another example. Liz walks with a speed of 5 meters per second and takes 95 minutes to reach Trisha's house. They then walk to the park with a speed of 2 meters per second and take 5 minutes to get there. Now you can't just say 2 plus 5 is 7, divide by 2 is 3.5 meters per second as an average, because it doesn't take into account that 95 minutes was spent travelling at 5 meters per second, but only 5 minutes travelling at 2 meters per second. So we have to go back and calculate our original distances, and then we do our final calculation with the total distance and the total time. Break it up into 3 again. Journey 1, Journey 2, and final calc. So in Journey 1, her speed was 5 meters per second and her time was 95 minutes, which becomes 95 times 60, which is 5,700 seconds. Now we're going to find her distance. Speed is equal to distance on time. We've got speed of 5, distance we don't know, 5,700 time. Distance equals 5 times 5,700, which is 28500 meters travelled. Let's look at Journey 2 now. Her speed was 2 meters per second. Her time was 5 minutes. And you should be having some alarm bells going off. Ding, 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 ding. Because it's in minutes and it needs to be in seconds. So 5 times 60. And this comes out to 300 seconds. We're going to find her distance. Speed is equal to distance on time. The speed was 2. The distance we don't know. The time was 300. So the distance is equal to 2 times 300, which is 600 meters. Okay, for the final section, we need to have our total distance, and this is equal to 28,500 at 600, and this comes out to be 29100 meters. Our total time is going to equal 5,700 at 300, which is 6,000 seconds. So our speed for these two journeys in average is going to be equal to distance on time, which is 29100 divided by 6,000, and it comes out that she's travelling at 4.85 meters per second on average across the two journeys. If you go to worksheet 3, question 5, you'll see another example of this type of problem. Good luck.